This is a bug, not the kind that crashes your computer or ruins a software launch. The kind with 6 legs, a narrow head, and a feeding strategy so quietly devastating that the medical community spent decades trying to understand why people in rural South America were dying of heart failure with no obvious cause, no prior diagnosis, and no warning at all. It comes at night, finds exposed skin, usually around the mouth or eyes, which is where it gets its name, feeds while its host sleeps, and leaves behind something that will not announce itself for years, sometimes decades. By the time the damage becomes visible, the perpetrator has long since moved on. Roses are red, violets are blue. This insect just gave you a parasite and you slept right through it. Everything you learned about dangerous parasites assumes some kind of immediate signal. A rash, a fever, and pain are things that tell the body a line has been crossed and triggers the response that might save it. Trypanosoma cruzi does not work that way. This single-celled parasite enters the body, disappears into the tissue, and begins a relationship with its host that can last 30 years before the bill comes due. It does not attack immediately. It does not overwhelm the immune system in the first wave. It waits. It integrates. It makes itself at home in the muscle cells of the heart so thoroughly that by the time symptoms appear, the damage has already been accumulating in silence for most of the host's adult life. If we mapped the full timeline of a Chagas disease infection onto a single calendar year, the acute phase, the part where anything detectable happens, would occupy approximately the first 3 days. The remaining 362 days would be silent. And somewhere in that silence, the heart would be quietly losing the argument. Meet Triatoma, infestans, the kissing bug, a member of the assassin bug family, which is a name that requires no explanation and absolutely lives up to its billing. It is roughly 2 centimeters long, mostly dark brown, and completely unremarkable to look at. It does not have venom. It does not have claws. It has no feature that would suggest, at a glance, that it is one of the more consequential insects in the Western Hemisphere. It feeds on blood, like a mosquito. And like a mosquito, it has evolved to do this without waking its host. The bite is painless. It does not need to rush. The house is its territory. It has all night. The parasite itself, Trypanosoma cruzi, is not transmitted through the bite directly. This is the detail that makes the whole system so quietly efficient. The bug's feces contain the parasite. When the host scratches the bite site, a nearly automatic response to any itch during sleep, they rub the contaminated feces into the wound or into the mucous membranes of the eyes or mouth. The bug does not inject anything. It simply creates the conditions, performs the exit, and lets human reflexes complete the transmission. Once inside, Trypanosoma cruzi does something that most parasites don't bother with. It invades the cells themselves, not just circulating in the bloodstream, but entering cardiac muscle cells, smooth muscle cells, nerve cells, and begins replicating inside them. The immune system detects the invasion and mounts a response. The infected cells rupture, releasing new parasites into the bloodstream. The immune system attacks. Some parasites are cleared. Others find new cells and disappear inside them again. The parasite does not destroy the heart. The immune system does. The parasite just made sure the immune system had no other choice. The math says a parasite this slow should not be this dangerous. But approximately 6 to 7 million people are currently infected with Trypanosoma cruzi worldwide. Most of them do not know it. Chagas disease, the illness the infection eventually produces, is the leading cause of infectious heart disease in Latin America, It kills more people annually in the region than any other parasitic disease, including malaria. And most of those people felt completely fine for decades before anything went wrong. The chronic phase of Chagas disease develops in roughly 30% of infected individuals. In those people, the heart gradually enlarges as the muscle weakens and scars. The electrical system that keeps the heartbeat coordinated begins to fail. Arrhythmias develop. Blood clots form in the dilated chambers. The first cardiac event, the moment the disease finally makes itself known, is sometimes a stroke and sometimes sudden cardiac arrest. Most diseases have the basic courtesy to introduce themselves first. Chagas considers that optional, but that is not what makes cardiologists go quiet when this topic comes up. There is no reliable cure for chronic Chagas disease. The two available anti-parasitic drugs, benznidazole and nifurtimox, are effective in the acute phase, when the parasitic load is still high and the damage is still limited. In the chronic phase, after the scarring has accumulated and the heart has already remodeled itself around the damage, clearing the parasite does not reverse what has been done. Standard cardiology investigates heart failure through the usual suspects: hypertension, coronary artery disease, and genetic predisposition. Chagasic cardiomyopathy looks different on imaging, behaves differently in progression, and responds differently to standard heart failure protocols, which is part of why it went unrecognized as a distinct clinical entity for so long. The mechanism driving the cardiac damage involves a persistent low-level inflammatory state mediated by CD8 positive T cells that continue attacking tissue even after parasitic load drops to undetectable levels. Current research suggests the immune system essentially learns the wrong lesson. Having been trained to attack cells containing the parasite, it continues attacking cardiac cells that display similar molecular signatures, even in the absence of active infection. The clinical applications are years away. But the mechanism is now understood well enough to know that the damage was never really about the parasite at all. It was about the response. There is something that sits uncomfortably in the story of Chagas disease that goes beyond biology. This illness has been endemic in Latin America for thousands of years. Trypanosoma cruzi, DNA, has been found in Chilean mummies dating back 9,000 years. This is not a new problem. It is one of the oldest ongoing public health crises in the Western Hemisphere, and for most of its history, it has received a fraction of the research funding, clinical attention, and international urgency given to diseases with comparable death tolls that happen to occur in wealthier populations. Chagas disease is classified by the World Health Organization as a neglected tropical disease. The word neglected is doing a lot of work in that sentence. The kissing bug does not discriminate by income, but the infrastructure that determines who gets diagnosed, who gets treated during the window when treatment works, and whose heart failure gets investigated for parasitic origin rather than written off as idiopathic, that infrastructure has never been evenly distributed. But if Trypanosoma cruzi can spend 30 years inside a human heart, invisible, silent, accumulating damage beneath the threshold of any symptom, we have to ask what other organisms have learned that same lesson. Because Chagas is not the only parasite that found the gap between infection and detection and decided to live there permanently. There are others. Some of them are considerably less patient.